Good evening. This is part 2 of my chapter 7 and lecture explanations. I just wanted to start by asking you guys once again to subscribe to my channel or like these videos if you like what is going on. If you like my explanations, if you have any suggestions for me, please give them to me. I really appreciate it. And let's get on with the show. It's really funny. My old professor used to always say that, and I hated it, but I think that's a very nice way to begin things, to get the show on the road. Anyways, alright, so next question. Same question, but different configuration. How many bands when cutting with BAM H1? This one is one band, even though there's two fragments. Why? Because here and here, because they're on opposite sides of the circle. Um, I guess you can say because they're equidistant. Equidistant. I don't know. I'm just trying to think of fancy terms to say that they're the same length apart. But both these fragments will be the exact same size. So you will only get one fragment because fragments are uh, determined by their size. Now, if you cut with BAM H1 and Echo R1, then you would get two different fragments. Why? One, two, and the third one is the same size as the two, even though there's three fragments. Okay, next question. Alright, another one of these, right? We're gonna get very good at these mapping games, right? So B, because you see two fragments here, that means there are two cut sites. E1 cut site and B plus E, we notice that here the 5 is the same, right? So that means the 3 fragment was most likely cut into a 1 and 2. What shows that? Well, if you look here, it's kind of hard to see. I'll zoom in a bit. Alright, I guess that doesn't really help. But these are like etched into eighths. But right here, cool. We see the B's that are should be 5 and 3, so that means there should be 3 in between. So 1, 2, 3. This one's good. 1, 2, 3. This is good. 1, 2. This is wrong because there's only 2 spaces between between the B, and 1, 2. So it means it's between B and D. Now E should lie somewhere inside the 3 fragment. Right here it lies in the 3 fragment, and here this one actually lies within the 5 fragment. So D is wrong, B is the right answer. Alright, next question. Cross these and these are performed. Following number of progeny for each genotype are obtained. What is the approximate distance between the two genes in the population? Okay, answer's already here, but let's go through and explain it. How do we find map distance? We do recombination frequency, right? So here we have this is the test cross between this one and this one. Big A and small b should be on the same chromosome. If we see a big A with a big B, see big A with a big B and small ab, this is a recombination with the small b and the big B recombining, right? Let me draw it out for you guys so you guys can see this a little bit more clearly. So along the chromosome, there's like an A and then an A, and then there's an B and a B, and right, just like before, there's like the two chromosomes. Now, if there is a cross between here, what we end up with is an AB over a BA. Oops, this one should be small a, this one should be small b. Alright, so regardless, still stands. This is what you'll get if they cross over. So if this one pairs with a homozygous, right, because it's a test cross, then the two recombinants will be AABB or AABB will be the two recombinants. Alright, so that means the two recombinants A, B, this one, and this one. So you add these two up, 67 and 80. There's no double recombinants because there's only two genes. And divide by how many. If you add up these all, you get 1,000. And ta-da, you just found your distance away. Cool? I think it's cool. Genetics is awesome. Alright, enough with the false enthusiasm. What does A something B plus mean? This means you have an allele and wild type allele. Okay, so plus means wild type. This oftentimes means a mutant. If it was wild type, it would be a plus, right? So even though if you had like a plus slash plus, let's just say plus slash plus, this is two different genes, but they are two different alleles, but this is a wild type for this one and a wild type for this gene. If you see this, that means it's a allele for one gene and a wild type allele for a different gene in the same animal, right? Alright, next one. In a certain species of slugs, angry controlled anglers, blah, blah, blah. Angry and beautiful. Dominant phenotype is that. Recessive is the small ones. For an experiment, what you want to do is you want to look for double. For an experiment you want to do, you need a lot of doubly heterozygous, beautiful, angry slugs with the recessive alleles in trans. You will get these by crossing two slugs from a set of true breeding labs you have. What cross will you perform? So what you want to do is you want to have you want to find which two slugs you're going to cross in order to get the heterozygous, beautiful, angry slugs. Okay, so right here, you need to get heterozygous slugs. So here, you're trying to find the possibilities that will end you up with this one. Let's go with A. If you cross a beautiful, angry slug with an ugly, meek slug, that means you're crossing a beautiful, angry slug. So beautiful is dominant. Might as well just put this. Sorry, angry slug. Angry is dominant and beautiful is dominant. Will you get this? Two slugs from a set of true breeding lab strains. Alright, so these are you're only allowed to cross true breeding strains. Okay, so if you cross a beautiful angry, so that means it's like AABB with an AABB. Then you will get AB from one, and you will get AB from another. And that might get you. Hang on for a second. This is the first time I'm seeing this. I mean, I went to lecture, but I didn't really think about it. Alright, so for experiment, what you want to do, you need a lot of double heterozygous. You need to get these by crossing two slugs from a set of true breeding lab strains. What cross do you perform? Alright, well, I'm just going to say A might get you the right one, okay? Because here you have a heterozygous AA, and this is a big B, small b. For answer B, like this one says, cross an ugly, angry slug. Just like before, you have an ugly, which is angry and ugly, with a beautiful, meek slug. So that means you have A, B, B. Then you're going to get a cross of A, B, and A, B, and that should get you this one as well. Okay, the rest of them don't work. Next one, you want to find the one, basically you want to find the one in the middle. How do we do this? Just like before, we take the least one and the most one. The most ones are right here. See, so this is SBH, and you have all wild types on this, and these are the parentals. And remember I told you all the rest of them are paired. So this one's a pair with a single recombination in between the S and the B. Right here is a pair with a single recombination between the well, the B is different, and here is your double recombinant. What do you see that's different between this one and the parental? This H and this H, which means that H is in the middle, so it can be BHS or SHB. Either one will work for an answer. Alright, here is map distance. We want to find out the distance between SHB. So the first step is to rewrite all of these in the correct order. So this would be like S, capital S, HB, this would be plus plus plus, this will be S plus plus, plus HB. You know, basically write everything down in the correct order. Then you look for the ones that are different. Here's a cross between S and H. So if you had a cross between S and H, you would have S plus plus, which is what you see here, which is where the 9 comes from. You'll have a plus HB, because remember you wrote them down the correct way. Plus HB is what you see here, so this is where the 10 comes from. Then you have to count in your double recombinant, which is right here, and the 0 just comes because there's such a small sample size, you didn't get 2 recombinants. You do that all over 100, which is the total, you get 0.2. You do that again for HB, and to calculate interference, you do a, observed double crosses over expected double crosses. And your expected double cross is this times this, your two distances multiplied times each other. And this is your answer. Be sure to know this, how to do this on the test. I can almost guarantee you that a problem like this will be on the test. Okay? Recombination frequency between S and B. Well, SHB. Between that, you just look at all the recombinants in between S and B, right? So that means this is a recombinant, this is a recombinant, this is a recombinant. Oh, sorry, this is a double recombinant, so it didn't. This one did not recombine S and B because the double recombinant re-switched them back over. And this and this. So these four, 1, 2, 3, 4, are what you get right here. So this is 0.28. So this is the best idea we have, right? So best estimate of map distance is 0.28. Sorry, the best one is these two added up, because when you add up the parts to the whole, you get a much more accurate than if you do the big one. The reason is because the double recombinants throw off your calculations. Okay, so know how to do interference, know how to do map distances, and there's not that many. Here's Hardy-Weinberg. There's not that many other questions you can ask on the test. Most of them will be calculation because those are easiest to grade, and the rest of the multiple choices will be on concepts that we went over in LARC lecture. So comment if you have questions, subscribe to my page if you guys like my videos, and definitely give me suggestions of how can I improve. I always here for you guys' help, and email me if you have any questions, any life questions, any girl problems, guy problems. I'm an expert in everything. I'm actually probably not, but I always have something to say, and I like hearing what I have to say. So let me know. I'll see you guys next time.